Hello everybody, welcome. Today you're going to be working on unit number 4, lesson 12, fractional lengths. So today you're going to be solving word problems that include fractions and fractions that need to be divided. You're going to be solving these by creating pictures or models. And also, I'm hoping that after you do this, you can put the fraction into an algorithm type of situation. Now, what kind of algorithm were we using to divide fractions again? Yes, we were doing keep and then change and flip. So we're going to be reviewing that as well. Okay, let's take a look at the first problem, shall we? Jada was using square stickers with a side length of 3/4 of an inch. So remember, we're always trying to circle important information to decorate the spine of a photo album. The spine is 3 3/4 inches long. If she had laid the stickers side by side without gaps or overlaps, how many stickers did she use to cover the length of the spine? Okay, so we have a lot of important information in this problem circled, and hopefully it's enough to work with. Okay, so what exactly is she doing? Yes, she is covering the spine of her book with sticky notes. And how long are these sticky notes? Well, each one is 3/4 of an inch. And how long is the book spine? 3 3/4 of an inch. So good. Right here we have the spine of our book, and we understand that it is 3 3/4 of an inch. Okay. And right here we have our sticky notes. And we understand that these sticky notes are exactly 3/4 of an inch. So we want to figure out how many of these 3/4 of an inch sticky notes we're going to need to cover the spine of the book. Okay, well, let's start to count them. Okay, so here's our first one, our first group. So we're going to copy that and paste it. Second group, copy that and paste it. Third group, and fourth group, and fifth group. Okay, that might be enough, but let's go ahead and count what we have so far. All right, well, let's see. 1/4, 2/4, 3/4, 4/4. So how much is that? 1. Perfect. Let's do it again. 1/4, 2/4, 3/4, 4/4. That's another one. 1/4, 2/4, 3/4, 4/4. That's another one. And 1/4, 2/4, 3/4. So good. That gives us our 3/4. Okay. So how many groups did we actually use to make this 3 3/4 book spine covered by sticky notes? Well, let's go ahead and count our groups, shall we? Okay, so our first group of 1 1/4 sticky note, and then our second group, and then our third group, and then our fourth group, and last but not least, our fifth group. Okay, so it took a grand total of 5 groups. Now you might be wondering, why am I just making groups of 3/4, but right here I counted to 1 whole? Well, down here I'm trying to count the wholes that would take us to get to this point. But remember, each group is only 3/4 of an inch. So that's why I highlighted just 3/4 at a time. Okay, so that's kind of the way it works. Okay, so what do we know? Well, we know that it's 1, 2, 3, 4, 5 groups total. 5 groups total. Okay, or you can even say 5 groups of 3/4 inch notes. Okay, now can we make this easier? Well, we drew our diagram, right? But maybe you want to use the algorithm to speed up the process a little bit, okay? So how might we do this? Well, we understand that the spine right here is 3 3/4 of an inch, okay? So that's 3 3/4, and we are dividing that by what? Well, we are dividing it by groups of 3/4, okay? Groups of 3/4. And then we need to get our answer, our quotient. So equals what? Okay, so how do we divide fractions? Perfect. We keep, we change, and we flip. Now this particular question presents a bit of a challenge, and that is the fact that what? Well, this is not an improper fraction. It's a mixed number fraction. So how do we turn this into an improper fraction? Perfect. What we need to do is we need to take the denominator and multiply it by the whole number and then add the rest of the numerator. And then what we're left with is what? 4 times 3 is 12, plus 3 is 15 over 4. Now what do we need to do? Change. We're changing that division sign to a multiplication sign. And last but not least, what do we need to do? Flip. Flip. So we're flipping the denominator with the numerator. And what are we going to get as an answer? Well, when we're dividing fractions, we always go across, multiplying as well. So 15 times 4 we know is 60. And 4 times 3 is 12. And remember, we think of this as a division problem. So 60 over 12 is the same as 60 divided by 12. And 60 divided by 12 equals what? 5. Okay, so there you have it. Now you understand why we were able to get 5 groups here and also get 5 groups when we used the algorithm. Okay, so we're going to just do one more to make sure you're feeling totally up to speed with where we need to be. So let's go ahead and read this question. And while we're reading, we are going to be underlining important information. Lynn has a square piece of artwork that is 7.5 inches on each side. She wants to frame it with paper clips. If each paper clip is 1.5 inches long, how many paper clips does she need? So how long is her frame altogether? Good, it's 7.5 altogether, okay? So we need to figure out how many what? Good, we need to figure out how many groups of paper clips, and remember each one is 1.5 inches long, will fit in order to frame her piece of artwork, okay? So what are we doing? We're figuring out how many groups of this are going to fit. Okay, so let's go ahead and get started. So here's our first group, and second group, and third group, and fourth group, and fifth group. So it looks like we got 5 groups all together again. But let's just kind of make sure that's exactly what we're looking for. So let's make sure we actually have 7.5 here, okay? So it looks like we have 1, 2, 3, 4, 5, and then 6, 7.5. Bingo. So let's go ahead and highlight our groups just to make sure we're on the same page with where we need to be. So here's our first group, and here is our second group, and here is our third group, and our fourth group, and last but not least, our fifth groups. So what's our answer? 5 groups. Okay, so, or 5 total paper clips, because the groups in this situation are the number of paper clips. Okay, so algorithm time. How do we solve this problem using an algorithm? Okay, perfect. So we have 7.5, and we must divide that by what? Perfect. We are dividing it by 1 and 1/2. Now, what's our problem here? Why are we going to run into trouble? Perfect, because we have mixed numbers instead of improper fractions. So before we can keep and change and flip, we must convert these mixed numbers into improper fractions. So how do we do that? Well, we multiply the denominator times the whole number, and then we add the numerator on both sides. And in this situation, 2 times 7 is 14 plus 1 is 15. 15 over 2 divided by 2 times 1 is 2 plus 1 is 3 over 2. Perfect. So now we have our improper fractions, and now what we can do is keep, change, and flip. Okay, so let's go ahead and get started. First one we are keeping, perfect. Second one we are changing, and how are we changing it? Well, we're changing it from division to multiplication. And last but not least, what are we doing? Flipping, flipping. Don't forget to flip, don't forget to flip. And then finally, what do we need to do? Good, we multiply across, multiply across. So that means we are left with 30 over 6. And we see that this is a fraction, but it really is a division problem too, right? Because simply 30 over 6 means 30 divided by 6, and 30 divided by 6 equals 5. Okay, so we got 5 using the algorithm, and we got 5 using the diagram. Okay, everybody, thank you for tuning in. I'm hoping that when you solve this problem, you are able to use diagrams as well as algorithms to come up with your answers. Thank you so much and take care.